Hello ladies and gentlemen, boys and girls. My name is Mr. Do and you're welcome to Mr. Do Scienceworld. So today we're going to look at differentiation. And we're going to look at two aspects of the differentiation. We're going to use the differentiation rule and then we're going to take derivative of a composite function as well. So let's begin by looking at the differentiation rule first. Okay. If I am given a function such as this, f of x being equals to x to the power n. So we're looking at the general way of differentiating this by making use of the differentiation rule. From the word differentiation simply means we're looking at difference. Okay, so we're going to take the derivative of this function, and if you want to take the derivative of the function, it means that we are just differentiating this particular function with respect to a given variable, which that variable is the what? Is the x here in this case. Alright, so now let's look at it. If I look at this, the general rule for these, which we can just simply write this as y also equals to what? F of x. So that in place of these, I can replace it with a y and still have this. So let's look at the general rule for this. The general rule for this is going to be that if I take the derivative, which is the f prime of x, that is just going to be that it's going to be n multiplied by the function that we were given minus what? 1. Because we are talking about what? Differentiation. So we're looking at what? The difference in there. Alright. This becomes the general rule for differentiation, or what we call the differentiation rule. This implies that, okay, if I look at this in another aspect, we can also have something like this, a function like this. Say I have y is equals to kxn. What are we going to have? Okay, if I have anything of this form, what we are going to have is, we just take the derivative as we have learned, that this is just simply equals to, the same thing that we did here is what we're going to do. So it's going to be n multiplied by kx n minus 1, and that becomes the word, the rule that we are going to make use of. This simply implies from here, if it happens that n is equals to 1, what is going to be the derivative? The derivative is just going to simply be what? Going to be equals to k. How do we arrive at that? Okay, if I take that this is 1, that means that we're going to have something like this, y is equals to what? Kx. So if it is y is equals to kx, then it's going to give us that we'll find the derivative of this function, and that is going to give me k, that here is 1, so 1 down multiplied by kx 1 minus 1. And remember that this is going to be 1 multiplied by the k, and this is going to be what? 1 minus 1 is going to be 0, so it's going to give us x to the power of what? 0. Remember, according to the exponential laws, we can see that any number or any variable raised to the power of what? 0 is going to be what? It's going to be 1. So if it is 1, this will become 1 multiplied by k multiplied by what? 1. And that is going to give us what? K. Which means whenever the value of what? Of n is 1, we are going to have it to be just equals to something like this. Okay, let's look at another way. Also, if I decide to take a derivative of a constant, say I am given y is equals to say c, where c is representing a constant like 5, 6, 10, 15 or whatever, what is going to be the derivative? The derivative is just simply going to be f prime, okay, of x, which is now going to be what? It's just going to be equals to what? Equals to 0. Why do we get 0? It is 0 because here we are talking about differentiating the function with respect to x, and here there is no x. So if there is no x in that particular function, then it means that we are going to have it to become what? Become 0. Okay, let's now look at this and look at some examples here. Okay, if I am given if I'm given a question and I'm told to find the derivative of the function, which I use f prime of x, this is still the same as what? The y, the x. Which means that I am differentiating the function y with respect to what? With respect to x. So f prime of x is the same as what? The y, the x. Alright, now let's go by solving some practical examples. Alright, so let's look at this problem that we have on the board. This is example number 1 that we want to look at. And we can see they said differentiate y equals to 3x to the power 4 and hence find the gradient of the curve at the point where x is equals to what? -2. So when you look at this, a function is given to us, and first thing to do is for us to differentiate that function. And now we are given a value at a particular point where we need to find the what? The gradient of the what? Of the curve at that particular point. So if you want to find the gradient of that point, it means we take the derivative, and after taking the derivative, we'll just substitute the value of what? X into that what? Into the derivative, and that gives us the answer that we are looking for. So let's begin by solving that. So the function itself, which is f of x, or being equals to y equals to 3x what? To the power of 4. This is what I'm given, and I want to find the derivative of this. If I want to find the derivative of this, I can just simply say the y, the x, because I'm differentiating this y with respect to what? With respect to x. So the y, the x is now being equals to, let's apply our differentiation rule. The exponent is 4, so that is what? 4 multiplied by the function that we were given, and then we said it should be what? -1. So what are we going to have? What we're going to have is just simply what? 4 times 3 is going to give us what? 12. Sorry. So that is 12x what? To the power of what? 4 minus 1 becomes what? 3. Now we have found the derivative. We need to find the gradient at the point this. So which means that I am looking for f -2. F -2, because the value of x now is -2. So I'm finding that value -2. Where is that function? So f prime of this at this point. And that is just going to give me 12 multiplied by, this is what? X, and x is -2, so that is -2, and the exponent what? Exponent 3. Right. Once I have this, what do I have? This becomes what? 12 multiplied by -2 exponent 3 is going to give us what? -8. So right now, when you multiply 12 by -8, you're going to have what? -96. Which means that the gradient at the point where x is equals to -2 is what? Is -96, which becomes the what? The gradient that we are looking for. Okay, so let's look at example number 2. Differentiate y equals to 3x squared plus 4x cubed. This is another function that we want to find the derivative. So we are trying to differentiate this, which means we are looking for the derivative of this function. So if I'm looking for the derivative of this function, what do? All that I need to do, remember, we can just simply solve this by finding the derivative of this and finding the derivative of this and checking to see if there are like terms, we add them together as we have there, and that is it. So we can either have it that there is a sum, which is the addition sign, or there is going to be what? A subtraction. Whichever one that we have, we can still make use of that. So I can write this as y, okay, or let me say f of x now being equals to say, or let's look at it this way, okay. Y is f of x plus g of x. So it's like this is a function and this is a function, and I'm trying to find the two functions so that I can add the sum of those two functions together after finding the derivative of each of them. So therefore, if I have it this way, it means I'm differentiating this and I'm differentiating this. So I can easily just look at it as, okay, oh, f prime of this is now what? Is 3. Remember, that is 2 multiplied by 3x2 minus 1. And this is going to give you 6x. And then I will look at g of x. G of x prime, okay, so I'm taking the derivative of g of x, which is 4x cubed. And that is also just simply going to be 3. Sorry, let me write it the correct way for you. Okay, so basically just going to be like g prime of x is also going to be 3 multiplied by 4x cubed minus 1. And if I take this, automatically I'll multiply these by that and I'm getting what? 12. And this is x. And that is what? 3 minus 1. So that will be what? This. So finally, I'm taking now the function of this. So the whole function now, which is this, and that is going to give me f prime of that plus g prime of this. And that is just simply what? It's just simply 6x plus what? Plus 12x squared. And that becomes the what? The y prime of that particular one. Yes. So that becomes my answer. We can solve it together straightforward from here without any problem, without going through this way. You just solve it straight away from here and just say, okay, you're looking for, which is the same. So just say you're looking for the y, the x, and then you differentiate this. You know, if you multiply this by this, you get then 6x. And now you are addition sign and you do the same thing to this. This is 12x to the power of what? 2. And that also. So we can solve it straight away like this, or you decide to break it down into this form, which is still the same thing. Okay, let's look at example number 3. Example number 3 says we should find the coordinates of the point on the curve with equation y equals to s cubed minus 6x squared plus 5, where the value of the gradient is -9. So here we are given the what? The gradient is of the value of the gradient is given, which that gradient there speaks to us of the what? Of the derivative of that particular function at the point. So if that is it, then, and we are told to find out what? The coordinates. So it means our interest now lies in finding the coordinates of the points. And if you want to look for the coordinates of the points, remember that coordinates would definitely speak to us of the x coordinate and the y coordinate, or the z coordinate when we're talking about what? Maybe the space. Right. And now we're going to look at this from this aspect, because there are only two variables here. Definitely speaks to us that we're going to talk about the x and the y coordinates that we're going to look for. So let's try out there and see how we're going to find this. I'm going to look for this coordinate there. So to look for the coordinates, I check it up and say, okay, I am going to look for the derivative, which is the y, the x, and I will equate that to -9. And then find the values of what? Of x. And that becomes the what? The coordinates that we're going to look for. So let's see from this point now. If I take it like this, what am I going to have? Take the derivative first. So to find the derivative is going to be the y, the x is now simply being here. Now we're not going to waste time again by bringing it and showing all, because now we understand how to do it. So it's going to be that this will be 3x squared minus 12x plus what? This is going to be 0, because remember this is a constant, so therefore it's going to be 0. I've taken the derivative of this function, taken the derivative of this function, and I've taken the derivative of this function. This is 0, so this is what? -12x, and this is what? 3x squared. Now I have found the derivative. So what do? It must be equals to what? -9. And then I will be able to find the what? The coordinate, because they said the gradient itself is what? Is -9. So that is equals to -9. Now I need to find the values there. To find the values, let's go ahead and solve that now. This is simply going to be 3x squared minus 12x, okay, being equals to -9. And I will just transpose the 9. And when I transpose it, I'm having 3x squared minus 12x positive or plus 9 is now equals to what? 0. This now has become what? A quadratic equation. And if you're having a quadratic equation, then we can solve this quadratic equation by either completing the square or by factorization or by making use of what? Quadratic equations. Any of them that you prefer to do is allowed to do. Alright, so let's see. There is a common factor here, so I'm going to divide through by 3 so that I will have what? X squared and then 4x plus what? Plus 3. And that must be equals to what? Must be equals to 0. Now what we have is a quadratic equation, so we can make use of either a factorization method or we can just make use of completing the square, or we use the quadratic word equation. Now from here, this is very easy to use word factorization. So I have -1 here and then I have -3 being equals to what? 0. And now I will equate each of them and solve for what? The values of x. So we can see that x will be equals to 1 or x is being equals to what? 3. And these are the what? The coordinates for that. So we can find the corresponding y values of each of these values here. We can find the corresponding values of y. You can substitute this into the function itself, and that is going to give us the value of what? Y at that particular what? Point, and then we can also substitute this into that as well and find the corresponding value of what? Of y. Right. Okay, example number 4. We are told to differentiate y is equals to, into bracket, 2x plus 1 into 3x minus 4. Right. We're going to solve this in a particular way, but as we move along, when we go into another section, we're going to solve similar problem, but we're going to solve it differently. Alright, but for now, let's look at it and apply differentiation rule in solving this. Right. So, if I have any given function like this, all that I need to do is I will expand this. And after expanding or remove the bracket, so after expanding or removing the bracket, then we will differentiate what? The function. So this, which is y is equals to 2x plus 1 into 3x minus 4, can be written as multiplying this by that gives you 6x squared, and then we multiply this by that, and then we are getting what? 8x. Multiply this by that, we're getting what? 3x, and then multiply this by that, and we're getting what? -4. And when I simplify that, this and this are like terms, so let's simplify that. We're going to get 6x squared minus 5x minus 4. And now this has become the function. So this is the same as the given function itself. And now we need to do what? We need to find the derivative of this function. So to find the derivative, and then I'll say that the y, the x, is now equals to 12x minus 5. And that is how to solve this kind of what? A problem. Right. Let's look at example number 5. Alright, so with example number 5, we are to differentiate these functions, and we can see here we are given x is equals to t squared minus 3t minus 2, and then the b part is z is equals to 4p exponent 8 plus 2p exponent 6 minus p exponent 3 plus 5. And the c we are given g of r is equals to 4 pi r cubed over 3. And we are told that we have to differentiate this function with respect to what? With respect to r. Which means that here the pi is becoming what? A constant. Right. So let's look at it and see. We can see that when we started, we were looking at what? The y, the x. Trying to give you this example to let you know that it is not only about y and x that we can what? We can differentiate. Whatever the variable is, we can take a derivative. So looking at derivative of different what? Variables. That is what we are just trying to look at now. Right, so let's begin with solving this particular problem. Right, number one. If I take the first one, I am given x is equals to t squared minus 3t minus 2. So it means I am differentiating x with respect to what? With respect to t. So I can just simply say that what? X is a function of what? Is a function of t. Okay, so x is a function of t, and that is now equals to what? T squared minus 3t minus 2. And now I can find the derivative of this now. So to find the derivative, now let's see from this point. If I want to find the derivative of that particular function, so it means I'm saying x prime of t is now equals to what? 2t minus 3. And that becomes what? The derivative of this particular one, of this function. Sorry. But that is the derivative of the function. So it is x prime of t is now equals to 2t minus 3. And that is the answer to that particular problem. Let's look at number 2, or the b part. The b part, we are now also going to differentiate this function with respect to what? P. It means z is a function of p. So if it is a function of p, then we will say that our z is a function of p. So we're taking the derivative of that, and that is just going to be simply, we're going to have 8 multiplied by 4, and that's going to be what? 32p. And when we subtract 1 there, we're having 7, and here plus this by that gives you 12p exponent 5, and now this is negative what? 3p squared, and that becomes the what? The derivative for this as well. So we've been able to find that, or we have taken the, we have differentiated the z with respect to what? The p. Okay, let's look at the last one, where we are given the function g of r is equals to 4 pi r cubed over 3. If I'm given this, I need to differentiate the g with respect to r. So differentiating that, I have g r is now 4 pi r cubed all over 3, and I want to solve this problem. So we apply the same rule. Look at this. This becomes g prime of r, and that is going to give me 3 multiplied by 4 pi r squared all over 3. And now remember, 3 is here, 3 is here. So finally, my g prime of r is now going to be what? 4 pi r squared. And that is the what? Is the derivative of what we were given. Okay, now we have understood how to differentiate or how to take the derivative of a function using a differentiation rule. Let's look at another aspect of a rule, like how to find the derivative of a composite function. The one word simply implies what? The chain rule. So let's look at the chain rule. The chain rule is like a situation where we have a function and there is another function. Okay, so function of a function. That's what we want to try to look at. Okay, this is a rule. We're not going to look at how we came about the rule. We're just interested in the application of the rule. So let's look at it. So this chain rule is just simply the y, the x is equals to the y du multiplied by du the x. Right. So we can see we have the y du multiplied by the u, the x. So that means that if I'm given any function, when you look at what we have here, if I cancel this and this, what I have is just what? The y, the x, which is the same as this that we have here. So this is what we refer to as what? The chain rule. Like, if I'm given a function like y is equals to, say, we're given like 4x plus 1 exponent 2. This. If this is given, then we can simply say that, okay, this itself is a function, and the whole thing again is another function. So I can let from here and say, okay, let u be equals to what? 4x plus 1. So if u is equals to 4x plus 1, that means that y can also be written as u squared, because the u is the one in the bracket here. So therefore we can write this as that. And once this is like this, we can apply the chain rule to solve that particular problem. So let's try and solve this using the chain rule. Now I have let this function be equals to u, and then the y is now equals to this. So what do I do? Here, this function is u. So I need to find the derivative of this function and find the derivative of this function as well. After finding the derivative of this and finding the derivative of this, I will then multiply the two together. So let's go find the derivative of this. We are going to differentiate the u with respect to what? With respect to x. So it's going to be the u, the x, and what was that going to give you? If I take the derivative of this is just going to be what? 4. And now I need to take the derivative of these as well. So I'll now become what? I'm differentiating y with respect to what? U. So that becomes what? The y, the u, and that is going to be what? It's just going to be 2u. But what is u? U is simply 4x plus 1. So I can just say that this is the same as saying 2 into what? 4x plus 1. And once I have that, we can go ahead and finish up and say, okay, now this is what I was given. So I need to find the y with respect to what? X. So that becomes what? The y, the x, and that is simply equals to what? The y, the what? The u multiplied by the u, the x. Okay. Now we're going to substitute the values and solve for that. So let's see what we have. The y, the x is now becoming, what is the y du? The y du is here, and that value is 2 into 4x plus 1 multiplied by, what is du the x? Du the x is what? Is 4. So what would this be? This is simply 4 multiplied that, I'll get 8 into what? 4x plus 1. And we can expand this and have what? 32x plus what? Plus 8. And that becomes what? Du dx. Straightforward. And then we'll have this, right, as the answer to that particular what? Problem. This is what we refer to as what? The chain rule. Or this is how you can find what? The derivative of a composite function. That means a function of another function. Okay, so if you look at what I have just done right now, this simply means in general, we can just say that y is now equals to a function, and this function is also what? Of another what? Function. So we have a function here, and there is another function. So there is inside function and there is an outside function. So we have the outside, which is f of what? G of x. And then we have the inside, which is what? G of x. And that is why we say it is a function of a function. They are two what? Functions that are combined together, and that gives you what we refer to as what? A composite what? Function. Alright, so let's look at this problem. Let's try and solve this problem for how to find the derivative of what? Of a composite function. Alright, so we are applying the chain rule now. Differentiate each function by applying the what? The chain rule. Start by decomposing the composite function into the outside function and what? And the inside function. So it means you must know what an outside function is and what the inside function is, so that you'll be able to then solve the problem. So let's look at number one. Number one, we are given y is equals to cos 3x. So which one is the inside function and which is the what? Is the outside function? We can see that here we can let u to represent what? 3x. And then if u is represented 3x, we can put in place of 3x u, so that the y itself will become what? Cos u. So the inside function is the what? Is the 3x. And then the outside function become what? Cos u. Right, so let's try and solve that now. If I go by that, my number one, I have y is now equals to cos 3x. And I'm saying that I'm going to let u to be equals to what? 3x. So that my y now becomes what? Cos what? Cos u. And then I can now solve the problem. So to solve this problem now, I know that I need to find what? Du, the x, because I'm finding what? U with respect to x, and then I need to find y with respect to what? U. So this becomes what? Du, the x, and the u, the x, is now simply going to be what? 3. And what is the y du? So the y du, this is where we are now going to take a derivative of what? Of a trig what? Ratio. Now this is a trig ratio here where it's cos u. Remember, each time that we take the derivative of a cos, it becomes what? Negative of sine. Alright, so cos u is going to give us what? Negative sine u. And therefore this is going to be negative sine u. But what is u? We know u, according to our question, we said we are letting u to be equals to what? 3x. So this now has become what? Negative sine 3x. Now let's apply the chain rule so that we can find the y, the x. So to apply the chain rule, remember we said the chain rule according to Leibniz is what? Is the y, the x being equals to what? The u, the x multiplied by the y du. Alright, so let's do the substitution and see what we're going to have. Right, if I substitute that, remember that my du, the x is what? Is 3. So that is 3 multiplied by what? The y du, and the y du is now negative sine 3x. And what is going to be my final answer? The y, the x is finally going to give me what? I multiply this, so I'm going to have negative 3 sine 3x. And that is the derivative of the function that what we were given. So this becomes our answer. Right, so whenever you are given y is equals to cos 3x, and we want the derivative of that, is going to give us what? Negative 3 sine 3x. Let's do example number 2. If we look at question 2, it said y is equals to the square root of 3x squared plus 5x. So y is now equals to square root of 3x squared plus 5x. And I want to solve this particular problem. So what do I do? Well, I need to find the inside function and then the outside function. My inside function, I'm going to let these to represent my u. So I'll say let u be equals to 3x squared plus 5x. So that my y now can simply be the square root of what? Of u. And square root in mathematics can just simply be what? 1 over 2. So this is u exponent 1 over 2. And now I need to find the function. I need to find the derivative of each of those functions. This is a function of u in terms of what? X. And this is the function of y in terms of u. So I'm going to find the u, the x, and that is going to give me 6x plus 5. And I have what? Y, the y, the u, that is also going to give me 1 over 2u. And then remember, this will become what? Exponent negative 1 over 2. Okay, now we need to go ahead and apply the chain rule. So the formula that we know is the y, the x is now equals to the u, the x, multiplied by the y, the u. So do the substitution and let's see. The u, the x is 6x plus 5. And now what is the y, the u? The y, the u is simply 1 over 2u negative what? 1 exponent negative 1 over 2. So this is also now 1 over 2. I'm going to now change the u. What is my u? Remember, u is this. So this can also be written as 3x squared plus 5x exponent what? Exponent negative. Let me write it out well. Okay. So it is 6x plus 5, and we multiplying that by 1 over 2 into what? Into 3x squared plus 5x exponent negative 1 out of 2. And we can then solve this problem. By looking at this, we'll bring the half out so that we're going to multiply 6s plus 5 into 3x squared plus 5x exponent negative half. Now let's try and change the negative exponent into positive. So if you want to change that into positive, this will become this into 6x plus 5, and then we'll multiply it by 1 over 3x squared plus 5x exponent half. And remember we said exponent half simply means square root. So I can then change this and then it will become 6x plus 5 all over what? Square root of, there is a 2 here, so multiply by 2 and then into this that we have here, 3x squared plus 5x. And that becomes the derivative that we were told to find. So the y, the x is just equal to this. Let's try and solve the question number 3 that we were given, and let's see. so let's see. This is example number 4. Sorry, example 3. So let's see. Under this particular, finding the derivative of what the composite function, we are given that y is equals to 1 over 3x squared plus x. So which one should be the inside function and which should be the what outside function? I can just simply let what u to be equals to 3x squared plus x, so that my y will become 1 over what? Over u. And then I'll be able to solve this problem easily. So once I'm given this, I'll find the u, the x, which is 6x plus 1. And what is the y? The what? The y du. The y du is now, this is 1 over this. This can be written as u exponent what? Negative 1. So if I have it this way, then the derivative of this function is now, sorry, this is just the y. Okay, this is the y. Okay, so the derivative of this function now, which is the y, the what? The u is now going to be negative what? Negative u exponent negative 2. Negative u exponent negative 2. Now I've gotten this and I've gotten this. So we can therefore find the what? The y, the x is now equals to the what? The u, the x multiplied by the y du. And from there we do the substitution and we can see that the u, the x is 6x plus 1. What about the y du? The y du is negative u exponent negative 2. So from here, we will just transform this. The negative will come out there, and that we're going to change the negative exponent into what? Positive 1. So now we're going to have negative out, multiplied by 6x plus 1. Okay, and now we are multiplying it by changing this one into what? A positive exponent. And now this will become negative into 6x plus 1 all over u. What is u? U is 3x squared plus x. So this will become 3x squared plus x. And there is a squared, so we put it there, squared. So the y, the x for this particular function is going to give us this. And that becomes the answer for this particular problem. Right. If you want to expand this, you can, but remember, if you expand it to be negative, negative, and that will not make us to see the beauty of this. So in mathematics, we just factor out the negative, and you leave it like this. It makes it look more what? Attractive. Okay, so as example number 4, we are given y is equals to sine squared x, and that is what we need to solve. So we remember that these can simply be written as y is equals to sine x and then all squared. So this is just an abbreviated form of this. Alright, so if this is the same as this, then I can say this is the inner function, and then the outer function will be that. So therefore, I will say that I will let u to be equals to sine x, so that I will have my y now becoming what? U squared. Then I can take the derivative of the y du. Okay, so the y du is now becoming 2u, and the u, the x, the u, the x is now going to be, when we take a derivative of sine x, it gives us what? Positive cos x. Right, now I have found the y, the u, and I found what? The u, the x. So we can then find the y, the x, which is simply the u, the x multiplied by the y du. And what is the u, the x? The u, the x is cos x multiplied by the y, the x. The y, the x is 2u. But what is the value of the u? The u is sine x. So I will do the substitution there, and that becomes what? 2 sine x. And this will simply give me what? 2 sine x cos x. And that becomes the what? The derivative of what we were given. Okay, so let's look at number 5. We are given this, and we want to find the derivative. If you look at this is different from the one that we are having as sine squared x. These and these are not the same. Now it is the exponent is just for the x alone, but here the exponent is for both the sine and the what? And the x. So these, we can't write this one as this. We can write it as this. If you write it this way, this is wrong. So this can only be written as y is equals to, say, this. Okay. Yeah, we can write this one as this. That is correct. But this is different. Okay. So now that we know this, what is the inner function? Well, I will let u to be equals to what? X squared, which is the inner function. So that the outer one is going to be y is equals to what? Sine what? Sine u. So our y is now equals to sine u, and the u is x squared. So let us find the u, the x, which is going to be 2x, and then let's find the y du, and that is going to give you negative cos, this is sine, so we differentiate, it becomes positive. So cos u. And once I have gotten this, we go back and use the chain rule. The u, the x multiplied by the y, the u. And now the u, the x, according to what we have solved, we got what? 2x. Multiplying it by the y du. The y du is now cos u. But remember, what is u? U is x squared. So we will do the substitution there, and that becomes what? Cos what? X squared. Right. So this also becomes the what? The derivative of this particular what? This particular problem. Right. We can't multiply this by this because you can see this is just what? Cos x squared. So they are not something that we can multiply together. So we just leave the answer as it is. Right, let's solve the last problem. Okay, so this is the last question that we are solving. We're given y is equals to the cube root of 7 minus 5x exponent 2. So if you're given this, I can see that this is the inner function, or we can transform this and write it like this. This can be written as 7 minus 5x exponent what? 2 over 3. So this is the same as this function. So if you can transform this into this, then we can say this is our inner function. So therefore, we will let u to be equals to 7 minus what? 5x. And we will have our y to be equals to u exponent 2 over 3. Okay, so now we've been able to express it in this form, and we said that, okay, our y is equals to u exponent 2 over 3. So if we find du dx, we get the u dx to be negative 5. Let's now find the y du, and let's see what we're going to have. So the y du is now going to be 2 over 3 u exponent negative 1 over 3. Now we have gotten this, and we know the value of u, so we can just replace the u with what? With its value that is here, which is 7 minus 5 what? X, and say that this becomes 2 over 3 into 7 minus 5x exponent negative 1 over 3. And now remember, once we have a negative exponent, we can change it and make it become what? A positive 1 by saying that this will become what? 2 out of 3 into what? The cube root of 7 minus 5x. Right. Let's go back and now apply our chain rule and take that the y, the x is now equals to the u, the x multiplied by the y, what, du. And now we'll do the substitution from this side and see what we're going to have. So if I want to do the substitution, let me clean the top here and continue from that point, because now the u, we know what the u, the x is, which is what? Which is -5. And we know what the y du also is. The y du is now here, so we're going to just solve them together. Right. So let's try and bring it together. Once we bring together the y, the x is now equals to the u is -5 multiplied by the y du, which is 2 out of 3 cube roots of 7 minus 5x. And now from here, if you multiply this, we're getting negative out, and this is going to give us what? 10 into what? 3 cube roots of 7 minus 5x. And that becomes the what? The value of what? Of the derivative of this particular what? Function that we are given. So that becomes the what? The value. Thank you very much for watching this video. Please, if you have not subscribed into our YouTube channel, please do so by subscribing into Mr. Do what? Scienceworld. So that as you subscribe, click on the notification bell so that each time we release any new video, you'll be the first person to watch it. Thank you and see you. Bye-bye.